Today we'll be discussing inside the agent loop, perceive, reason, act, observe. This is for our series on AI cloud architecture. Subscribe to the channel and like this video for more great cloud tips. Agent systems are part of the decision layer of AI cloud architecture. What is an agent loop? An agent loop is a control loop that repeats perceive, reason, act, and observe. Each pass builds context. It lets the model decide, runs tools, then folds results back. That cycle turns a single-shot LLM call into multi-step agentic work. The four phases are a teaching model for how agency runs in production. Perceive assembles what the model can see. Reason chooses a tool call or final answer. Act is side effect execution. Observe records the tool result for the next pass. Most production failures are a bad phase or a broken handoff between phases. Once you see the agentic loop, you design tools, budgets, and stop rules. You stop hoping a longer prompt will fix runs. Perceive is context assembly, not robotic sensors. On turn one, you pack system policy, tool schemas, and the user goal. Later turns add history, prior tool results, and short-term trajectory state. What you omit shapes the next decision as much as what you include. If a tool error drops out of the prompt state, the model may retry blindly. Reason is the model call that picks the next step from the context package. The choice is usually a structured tool invocation, a clarifying question, or final answer emission that ends the loop. Some stacks surface a reasoning trace or thought step before the decision. Others only show the call or text. Reasoning stays bounded by the model and by the window you assembled. Why force tools when context is enough? Forcing tools when context is already enough wastes cost and latency. Act is where side effects happen. Search, database reads, ticket updates, and code edits. Why own the host runtime? The host runtime is the tool executor. The model only proposes a structured tool call. Your code must validate arguments, enforce permissions, apply timeouts, and return a clear result envelope. Schema validation of tool arguments catches bad calls before they hit production systems. Amazon Bedrock Agent Core Harness can own that full act and observe loop, model, tools, memory, and recovery in an isolated session. MCP under the Agentic AI Foundation supports multi-round-trip tool results, so a tool can pause for input mid-call without a sticky session. Observe writes environment feedback into the agent trajectory. The model doesn't magically remember the call. Your loop must append tool name, args, and tool result. That observation becomes part of the next perceive package. Without that right, you've got structured output, not a closed control loop. Log each decision, tool summary, latency, tokens, and stop reason. The trajectory is your debug artifact. OpenTelemetry GenAI semantic conventions standardize spans for model turns, tool calls, and agent orchestration across hosts. Observation feedback is the feedback arrow that turns one completion into multi-step work. A ticket lookup shows it. Resolve the org ID, count open tickets, then answer with the number. Each observe handoff between phases gives the next reason step new evidence. Multi-agent systems still use the same physics. A handoff is observe for the next agent. Lang graph-style graphs still consume context, act, and return observations on each node. The OpenAI Agents SDK ships a built-in runner that keeps calling tools until the task finishes, pauses for approval, or hits a stop. Teams overload the word turn, so budgets go wrong when definitions drift. A user turn is one human message. A model turn is one LLM completion. An agent iteration is one pass through perceive, reason, act, and observe. A tool turn is one tool execution inside that iteration. When someone says max 8 turns, ask which definition they mean. Production caps usually limit model turns or tool calls, not human messages. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. What happens without a stop? Without a stopping condition, the back edge is infinite and runaway loop risk is real. Max turns, goal checks, idle timeouts, dollar budgets, and user cancel are first-class design. Infinite loop risk doesn't vanish because the model is smarter. Thrash still happens. Amazon Bedrock Agent Core, Microsoft Foundry Agent Service, and Google's Gemini Enterprise Agent Platform, the evolution of Vertex AI, all rest on host-owned stops. Agent Core runtime can place each session in an isolated micro VM. Optimization turns production trajectories into fix and validate loops. Don't celebrate long trajectories as more agentic. Celebrate the shortest evidence path. Some models request parallel tool calls in one reason step. Act fans out, observe concatenates results, and the next reason step sees the batch. Independent lookups get faster when you fetch org, tickets, and policy in one wave. Error handling gets harder when one of three tools fails and the others succeed. Keep result envelopes uniform so partial failure stays readable in the next context package. React interleaves reasoning and acting inside the same loop shape. The agent loop is the general control pattern. React is one policy for how reason and act alternate. Plan and execute plans first, then run steps with fewer wasted mid-course calls on long work. Fixed workflows win when step order is known. A full control loop wins when evidence must decide the next move. Frameworks hide the while loop. They don't remove your job to design tools, context, and stops. Google ADK's runner drives the same cycle onto the Gemini Enterprise Agent Platform's agent runtime. Vercel AI SDK tool loop agent keeps stop when and host side tool execution explicit. Every iteration resends growing context unless you trim or cache. Context growth is mostly repeated system text plus an expanding trajectory of tool results. Trajectory trimming and summarization keep the perceived package inside the window and the bill under control. Designed for the shortest evidence path across Bedrock, Azure OpenAI, and Google Gemini hosts alike. Owning the loop makes multi-step goals diagnosable instead of magical. You can point at a bad handoff when a run stalls, wastes tokens, or picks the wrong tool. Cost and reliability improve when schema validation, clear tool results, and hard max turns sit in the host runtime. Operations get a real trajectory to log, replay, and evaluate rather than a single final string. Skip a free-form agentic loop when step order is stable and known. A single-shot LLM call or a fixed workflow is cheaper and safer for pure drafting and known lookup patterns. Full loops add latency, context growth, and runaway loop risk that you must actively bound. Use the loop when intermediate evidence must decide the next move. Use a workflow when it doesn't. An agent loop repeats perceive, reason, act, and observe until a stopping condition ends the run. The host runtime executes tools, records the trajectory, and owns stops. The model is the reasoner inside that system. Design each phase and every handoff deliberately, and most model failures turn into fixable engineering problems. Thanks for watching and listening to this, and subscribe to the channel. Find a lot more articles and guides on systemsarchitect.io.